Hey guys, today's notes are going to be pretty simple and pretty straightforward, so hopefully it will be the same for you and you're on board with that. We are going to look at arcs and area of sectors, so basically arc lengths, which we briefly talked about when we were doing radian and degree measure, but we're going to look at it a little more specifically today. So the length of the arc is literally the part around the circle that we're talking about. So a piece of the circumference. So the length of an arc is represented by 2 pi r, which is the circumference of a circle, and then the segment of it that we're talking about. So just the fractional piece of the circle. So in order to do that, you just take the fractional piece of the circle that you have, divide it by 360, and then multiply by the circumference. So it's just a part of the circle. So for example, we have this circle right here. Find the arc length. So pretty straightforward. We have 50 degrees of a 360 degree circle times 2 pi times the radius. Put that in your calculator. That's all you have to do. And you get about 3.49 centimeters. So what that means is this length right here is 3.49 centimeters. All right. Then we have the area of a sector, which is going to be very similar in terms of it is just a ratio of the area of the whole circle to the ratio of the piece that you have. So in general, it's going to be that percentage or piece of the circle, so theta over 360, and this time times the area of a circle. All right, so two formulas you already know, circumference and area of a circle, and then just times the piece you're looking for. So in this case, find the area of the sector. We're just going to have 40 over 360 times pi r squared. And you should get about 34.9 centimeters squared. All right, so this whole area in here is 34.9 centimeters squared, the area of the shaded region. Okay, just wanted to make sure I put my units on the previous one. All right, so in example 3, it's just putting everything together that we have learned recently. So we have this segment or piece of a circle, and we want to find, for this shaded region in here, we want to find the perimeter and we want to find the area. All right, so we're going to start with part A, which is to find the perimeter of the shaded region. So the first thing we need to know is what is the length of this arc out here. So we have 40 over 360 times 2 pi times 8. And we get that length of the sector, which is about 5.59 centimeters. So we have that, 5.59 centimeters. And now what we need is the length of AB. All right, if we're finding the perimeter, and we can use law of cosines for that. So basically, AB squared will equal 8 squared, and our other side is also 8. So plus 8 squared minus 2 times 8 cosine of the included angle, which is 40. You put all that in your calculator, and you get AB squared equals 29.946, or AB equals about 5.472. So we can find the perimeter just by adding that piece, 5.472, plus the length of the arc, which is 5.59, and we get about 11.1 centimeters. So that is the perimeter of that piece. Now we want to find the area of that little piece. So the first thing we're going to do is find the area of the sector of the whole thing, and we will get 40 over 360 times pi times 8 squared, and that gives me 22.34 centimeters squared. So that's the area of the sector. And then we need the area of the triangle. All right, and in order to do that, we can use this specific formula that we learned in our other class, 1/2 AB sine C, which gives me 1/2 8 sine of the included angle. All right, and that gives me the area of an oblique triangle, so a non-right triangle. And that gives me 20.57 centimeters squared. So we just subtract the 2, and we have our little tiny piece left. And that is literally all we're doing today. So arc length, area of a sector, and then being able to put together some of our previous formulas in order to find a small piece like we just did right here. And that should be about it.